today we're going to start our last little mini unit for the last couple of weeks of school before your summer break. We're going to do a little recap of some angle stuff today. For many of you, you would have done a lot of this in grade 5, so bear with me. And obviously if you haven't done it before, then I'll start from scratch and hopefully it will teach you something or remind you of something you've done before. So let's jump straight in. Let's have a little look at that little picture there. We can see we've got the same angle twice. So when we measure angles, we can talk about measuring the interior or the exterior, and we can see here it's kind of like measuring the distance between. Here it's measuring the distance outside. Two different ways we can measure the same pair of lines, and we're going to have a brief look at both today. But hopefully one thing you'll notice is that they go together as a little pair. Ooh, don't need to know about that. So moving on, something you did in grade 5, for those of you who are here, is classifying. So that's taking an angle and just giving it a name, not like Jeff or Bill, but proper name, like a mathematical name. And there's three main categories which we're just going to recap today. The little small ones, like this one here, we call acute. They're less than 90 degrees. 90 degrees, of course, being the one that looks like that. If it's between 90 and 180, so 90 would be this one here. That's 90 degrees, and 180 would be like that. If it's between those two sizes, then it would be obtuse, like this one here. Bigger than 90, but less than halfway. And then all the really big ones are reflex. So those are the three categories. We also often, to make things easier, we break things up into little blocks. So a whole turn, like a whole circle, is 360. If we do 3/4 of the way around, and notice it's all going clockwise. Clockwise is like this, yeah. We've got 3/4, half, and a quarter, and we often talk about these in maths. We can also see this one, not only is it 3/4, it's like 3 right angles. You've got one here, and one here. 1, 2, and 3. And obviously the other ones that's like 2 right angles, this one's 1 right angle, and that one's like 4 right angles, because a right angle is a quarter turn. The other common way you might see angles being talked about in the real world is with something called bearings. Bearings is when we talk about north, south, east, and west, going clockwise around. So again, we're always talking at the moment about going round like this, going clockwise, north at the top, south at the bottom, east on the right, west on the left, going round a full 360 degrees. So east would be 90 degrees, it would never be anything else because you're turning like this. Similarly, west, you have to go all the way around, you can't just jump straight down to the left, you have to go all the way around to the right, so west would be 270. And people use a compass to navigate around, and this is how people decide where they're going to go, like on a walk, or if you're flying a plane, or a boat, not flying a boat, navigating a boat. Okay, let's talk about more of what we're going to do today. So let's just recap. The two first things we're going to talk about are what we call on a line and at a point. First one here, we can see we've got an angle. Going to the left this time, because we know angles in the real world can go in any direction. It's only on a compass that they go clockwise all the time. So here's an angle. As we can see, it's half a circle. So an angle like this we call on a line, because it's literally on this line here, a straight line. And they add up to 180 degrees. Here we've got this angle. Again, it's going all the way around. One full turn, or at a point. That's not one word. This is at a point, because this point here is like the middle of the circle, and if we go all the way around, it's 360 degrees. These are what we call our first two angle facts. Facts because they're always true. How can we use that in questions? Let's have a look. Let's imagine I had these two questions. These are examples, but you're going to do questions like this today, and we want to find these two missing angles. Well, we can start off by saying we know this whole angle here, the whole thing, must be 180 degrees, because it's half a turn. Similarly, the one on the bottom is 180 degrees. So if we know that bit at the top adds up to 180 degrees, we know 45 and something and 55 make 180 degrees, because all together is 180 degrees. So we could say, well, if I put 45 and 55 together, we're going to get 100 degrees. So what more do I need to make 180? I need 80 degrees. How could you type that into the calculator? Well, you could have said 180 is the total, and you could subtract the two angles that you have, and this would have given you 80 degrees. So that angle there is 80 degrees. We use a smaller pen because it's a bit fat and messy. We can follow the same logic here. This time, however, we've got a whole turn. So we've got 360 degrees. If we subtract the angles we have, well, take away the 150 and take away the 70, what's left over must be that missing angle. So we type that into the calculator and it says 140 degrees, and that means that that missing angle is 140 degrees. And it's as easy as that. What do you start with? And then you subtract the angles you have. Let's look at a slightly different example. Here, in this one, we've now got 4 angles, but the logic is still the same. You start with your 180 here. Here we've got that whole turn, so we're going to start with 360. And we're going to subtract the angles we have. So here we're going to subtract 62, 27, and 45, and use your calculator. Here we're going to subtract 92 and 124. Sometimes what people like to do is they say, okay, I'm going to add these together. So they say, okay, I'll add them and subtract them all in one go. That's also fine. You've got 2 options. Both of them will give you the same answer. And then you say, okay, 180 minus, and you add them together. 62 plus 27 is 89. 89 plus 45 is 134. And the answer you're looking for is 46 degrees. And if you look at that, it's about half a right angle, so that looks about right. Or you can do it in one go. 360, and you minus 92, 124. Like I said, do it on the calculator, and it will give you, or you can combine them to get 216. Again, the calculator, if you just type this into the calculator, it will give you the answer you need. You don't need to add them together, but you can do, and that will give you 144, so an obtuse angle. So that's angles at a point and angles on a straight line. At a point, because they're all round one point, and on a straight line. What about different shapes? What about triangles? Well, first thing we need to talk about in triangles, again, just like we saw in that first picture, there's 2 types of angles in a triangle. There's the angles inside and the angles outside. So here we can see that we've got angles inside, A, B, and C. But we do have like their angle pair, if you will. So like B, for example, is inside, and then it's got an angle that goes with it outside. And together they make a straight line. We're today going to talk about the interior angles, but later on next lesson we will be talking about the exterior angles as well. And this is the same for any straight-sided shape. You've got interior and exterior angles. So let's talk about the interior angles. Okay. Well, first of all, we have triangles that, when we look at their interior angles, are like special case. We've got isosceles, so here we can see it's got 2 equal interior angles. We call that isosceles. We've got equilateral triangles, that's where they're all the same. And they're all 60 degrees. We'll come back to that in a second. And finally, we've got scalene, which is where they're all different, 3 different sized angles. 3 different sizes. Now let's think about this one here, this equilateral one. We know that all of them are 60. We've got 60 degrees 3 times. That's 180 degrees altogether. Now I am going to share on the Teamy post today a video that explains why in a lot more detail of why triangles add up to 180 degrees, but for this video we're just going to focus on how to use these angle facts. So we're just going to say the key thing is that if we take these three, 1, 2, 3 interior angles, we can say that the interior angles, just like that equilateral triangle, interior angles of a triangle add up to 180 degrees. And this is for any triangle, whether it's scalene, isosceles, equilateral, just like a straight line. If you would imagine we cut that bit out and put it here, then cut this one out and put it over there as well, we'd end up with something that looks like this. A, B, and C, and that makes 180 degree angle. So how can we use this? Well, let's just think about this. Remember, this is just for triangles. Other shapes are different. We know, just like our angles on a straight line, we've got 180 degrees here. If we take away the angles we have, then whatever's left over is our missing angle. So A is 60 degrees. And it's that straightforward. There's more complex questions, but that's pretty much it. We could do that with the triangle having a missing side anywhere, so even though it's in the top right, it doesn't matter. We could say 180 degrees minus 81 minus 62, and that gives us 37 degrees, so that missing angle is 37. Again, 180 degrees in total, take away the angles you have, and that gives you that missing angle, not question mark is something, sorry, 132, so it's going to be 48 degrees. The other thing to note for a triangle, and this is an important fact if you get on some of the later questions, the more challenging ones, is that these angles here, an interior and an exterior angle, form like a little pair. And hopefully we can see that they're on a straight line. So an interior and an exterior together, and this is when notice they're like two together. We're not saying like this one and this one. Okay, we're not saying that. They have to be like together and touching. But when we add them together, they also equal 180 degrees. Because they're on a straight line and they make that half turn. And that's the same for any straight-sided shape, but only when they're touching. Okay, finally, we're going to talk a little bit about symmetry. There's two different types of symmetry. So the first type of symmetry we talk about is line symmetry. That's just looking for a straight line. Let me put my ruler tool on. A straight line. If you had that shape in real life as a piece of paper and you folded it along this line, it would be the same on both sides. So for example, if I drew a straight line, let's do a nice thick one, down the middle of this shape, not a great straight line, but there we go. And if I can just move it to the side, let's remove the whole thing, isn't it? Let's try again. Straight line, down the shape, it's the same on both sides. But there's other ways we can do this as well. We can do it this way, we can do it this way, and we can do it this way. So we can say that this shape has 4 lines of symmetry. 4 lines of symmetry, there's 4 ways you can fold it in half where it's the same on both sides. If I show you an example of not a line of symmetry, let's imagine I drew this line here. Let's do it straight. Okay, this black line here, if you folded it along there, it would not be the same on both sides. So it's just when it's the same on both sides. We can also talk about rotational symmetry. And rotational symmetry is, as the name suggests, about turning the shape. Now I've got this shape copied twice. Let's think about this A at the top. At the moment, those two shapes are the same. Let's imagine they're perfectly the same size. The A at the top, they are the same. Now I'm going to use my fact I've got electronic means. We'll be able to turn it. So we're just going to see, if I turn this shape around all the way so the A is back to the top, how many times does it look the same? So if I turn it like this, for example, we can see it's not the same. It's kind of the same shape, but it's not looking the same. If I turn it 90 degrees, a quarter turn, however, we can see it looks the same. It looks like a plus. So that's one way we can do it. We can go again, and we can see there's two ways. We can keep going, 3 ways, and back to the beginning. There's 4 ways I can have this shape to make it look the same. So we say that it has an order of 4. Order just means rotation symmetry, and there's 4 ways I can have the shape where it looks the same. So it has, this shape has a line symmetry of 4 and an order of 4. Let's look at one more shape finally. When we look at this one, we can see that I can split it down the middle, 1, I can split it across the middle, 2. If I split it this way, is it going to look the same? Well, if you folded that in half, that side there, let's do a different colour, would kind of come through there and it would meet here. Yeah, which if you think about it, that's not where the corner of the shape is. So this one, that diagonal is not a line of symmetry. So there's only 2 lines of symmetry here. If we were to take the shape, let's make sure we mark the top. Mark the top with a little A. If I was to take this shape and turn it around, okay, we can see if I go a quarter turn, this time it doesn't quite look the same. A half turn does, and I keep going round, a bit slow on the, bit small there. So there are 2 ways. So we can say this has got, it won't always be the same. This one, it's got 2 lines and an order of 2. And that is a basic recap of symmetry. So that's symmetry. Let's finally just recap the angles things. 3 things you've looked at today. We've got angles at a point, that's a whole turn. Angles in a straight line, that's a half turn. And a triangle adds up to a half turn. Use these facts to help you and see how you get on today.